Hello everyone, welcome to our channel. This is Dinesh MA working as Assistant Professor in the Department of Electronics and Communication Engineering, Maharaja Institute of Technology, Mysore. In this session, we will understand the concepts of communication. We will look into the block diagram of an communication system, the transmitter and receiver systems block diagrams, the modulation process, the need for modulation process. Basically, the communication can be defined as the process of transferring information from one point to another point, where the processes involved are sending, receiving and processing of information by electronic means. So, this is how we define the communication system. So, in the course of time, we will understand what are the different things involved in processing the system. First, let us get into the block diagram of communication system, where we will be having different things involved such as information source, transmitters, receivers, channels and the noise and also the destination. So, let me draw the block diagram for the electronic communication system, or this can also be called as electrical communication system. So, first of all, we will be having information source. So, now this information source is the origin of the information. For example, if the audio signal is the information source, then we will be using the microphone as a transducer. We have learned transducers are the one which will be converting energy from one form to another form, and the microphones or the transducers which will be converting the audio signals into electrical signals. So, if I consider audio to be the source, and this audio will be using here a microphone to convert the audio signal into electrical signal, and this signal, the electrical signal from the audio signals will be given to next thing called as transmitters. The next block we have is transmitter. So, transmitter is responsible to process the data and send it across the channel. So, here transmitter also does something called as encoding, or this is called as modulation. So, here there will be chance of the distortion getting added with the signal. So, transmitter encodes the data or modulates the data. We will understand what is the encoding or modulating. So, then after processing the data, it will be connected to channel. Channel is the means through which the data will be carried. Say for example, we have twisted pair wires where signals, electrical signals will be carried on that, or we can also use coaxial cables. We have also have optic fiber cables which carries the light signals, where the audio signals or the information signal will be converted into light energy, and that will be transmitted over those OFC cables. We can also send the data over the space. Likewise, depending on the application, the channel also varies. So, this channel is going to carry the processed data. And here we have another block that is called as noise or distortion. So, channel is the place where there is higher chances of adding noises into the signal. So there could be any source of noise, like even thunders, lightning will be sources of noise. So while the data is getting transferred through the channel, so through some source there are chances of noise getting added into the signal, and from the channel will be giving signals to something called as receivers. So what the receiver does is, receiver, just like the transmitter, along with transmitting the data, it also does other process like encoding and modulation. The receiver, along with receiving the signal, it processes the data, and we call these as decoding or demodulation. So receiver receives the signal, processes the signal so that human can understand the data. So after this, we'll give this signal to the destination. So what we'll be having in the destination is, if the signal is audio, then we'll be using some sort of transducers here. So in case of audio signal transmission and reception, the transducer used is going to be a loudspeaker, which is going to convert the electrical signals into audio signals. So these are the different processes involved in the communication system. So we have information source, where we'll be using a transducer that converts the information into an electrical signal. So that may be, if in case audio signal is the source, then transducer used is the microphone that converts audio into electrical signal, or if the data is image, then transducer used may be scanner or camera, something like this. So that information signal in the form of electrical signal will be given to transmitter. Transmitter processes the data, and then it hands over the signal to the channel. Channel carries the signal where noise may get added, and then this data will be given to or received by receiver. So where receiver processes the data again so that humans can understand it, and further it will be given to destination, where again there will be a transducer. For example, if it is audio, we will be using loudspeaker. Now we will understand what the transmitter and the receiver does, or different block diagrams, different blocks what we will be having in the transmitter and receiver. So now we will look into the block diagrams of a typical radio transmitter and a radio receiver. So first we will get into radio transmitter. So radio transmitter has different blocks in this. So the first one is the crystal oscillator, and from the crystal oscillator the signal will be given to different stages of amplifiers, where the first one is the RF buffer amplifier, and from the buffer amplifier the signal will be further given to the RF voltage and power amplifiers. So we will give the signal to RF voltage and power amplifier, and from power amplifier further the signal will give to the one more amplifier called as RF output amplifier. RF power output amplifier. So we will also be having a transmitting antenna, and also the RF transmitter or the radio transmitter will be having other blocks like, I'll just come to each individual blocks. So here we'll get started with the modulation process. So here we give the modulation in signal, and this will be given to modulation process. So the signal is going to be modulated at this block, and further this will be given to next stage, what is called as modulation voltage amplifier. Modulation voltage amplifier, and after this will be given this to modulation power amplifier. Modulation power amplifier. So this is the block diagram of a typical radio transmitter. So as we can see here, we have different stages like amplification and the carrier signals, the generation of high frequency carrier signals and modulation, and then the power amplification, voltage amplification. These are the different processes involved in this. So all these things will make sure that the signal will be processed and amplified to the required level so that we can send the data to the longer distances. So here you can see something like crystal oscillator, which is going to generate stable high frequency signal, and generally this signal will be called as carrier signal, and on this at various stages amplification will be done and also modulation will be done. Modulation is the process where we'll be varying the parameters of the signal. So any signal will be having basically three parameters. One is the amplitude, second one is the frequency, third one is the phase. And in the modulation process will be varying any one of these parameters, and depending on this we have different types of modulation called as amplitude modulation, frequency modulation and phase modulation. These are these can also be categorized into two things. One is analog modulation, the other one is the digital modulation, wherein analog modulation will be having frequency modulation and amplitude modulation, whereas under the digital modulation techniques we have various phase modulation techniques like ASK, PSK, FSK. So different types of digital modulation techniques we have. So accordingly the signal will be boosted to the required level, and using an antenna these signals will be sent out. So this is a typical radio transmitter what we have. Now we'll look into a typical receiver, radio receiver. So this is also called as super heterodyne receiver. So this starts with a receiving antenna, so which will be given to an RF stage. So RF is radio frequency. So radio frequency will be received at this particular stage, and then this will be given to something called as mixer. This is mixer, and to mixer one more signal will be given from a local oscillator. Local oscillator, the mixer is going to generate the difference of these two signals. So then these two signals, the difference of these two signals will be given to intermediate frequency amplifier. So this is going to amplify this received intermediate signal to the required level, and then this will be further given to next stage called as demodulator. So where this is going to recover the signal back. So in the transmitter section, we will be modulating the signal, the form of the signal would be changed there, and that signal will be recovered to its original form using this demodulator, and further this will be given to the audio voltage and power amplifier. Audio voltage and power amplifier. So further this will be given to a transducer, as I said here in this case a loudspeaker. So this is going to convert the electrical signal into audio signal. So this is the block diagram of typical radio receiver, and this is the block diagram of typical radio transmitter. So these are the things involved in any electronic or electrical communication system. Now let us understand what is modulation and what is the need for modulation. Modulation can be defined as the process of superimposing the low frequency message signal on the high frequency carrier signal. Message signal is also called as baseband signal. So the process where we will be superimposing this low frequency baseband signal on the high frequency signal is what called as the modulation. So here basically baseband signal will be involved. So the frequency of this will be less in nature, so it's a low frequency signal, and this will be given to the modulator, and modulator also receives another input, what we call as carrier signal. So carrier signal will be basically a high frequency signal. So what we do in the process of modulation is the parameters, any one of the parameters of the carrier signal will be varied in accordance with the instantaneous value of the message signal. So this is what we do. So this signal will have the parameters like the amplitude and the frequency and also the phase. So now if I have to vary the amplitude, where this process is called as amplitude modulation, the amplitude of the carrier signal will be varied as per the instantaneous value of the message signal, right. So this is what a modulation process is all about. So considering the amplitude modulated signal, so this would look like this. If this is the base signal, carrier signal value will be varied like this. The amplitude of the carrier signal will be varied according to the instantaneous value of the message signal. So this is how an amplitude modulated signal looks like. So what we are seeing here is the frequency of the carrier signal has been kept constant, whereas the amplitude has been varied as the message signal varies. So this is what we do in the modulation process. Now let us understand what is the need of modulation. So number one, modulation reduces the height of antenna, reduces height of antenna. Now the height of antenna is related as lambda by 4, and lambda we know this is given by, lambda is the wavelength which is given by C by F. So this can be written as C4 by F, where C is the velocity of the light, F is the frequency interested. Now say for example I want to have a signal of 10 kilohertz. We know the audio signal range is 2 to 20 kilohertz. Now for example, if I am considering a signal of 10 kilohertz, let us find out what would be the height of the antenna required to transmit this signal. So let us substitute this here. So C is height of the velocity of the light, which is given by 3 into 10 to the power of 8 and 4 into 10 into 10 power 3, and this would give me, if I simplify this, this would give me 7500 meters, which is nothing but 7.5 kilometers. So this is an impractical size of antenna. So height, an antenna of the height 7.5 kilometers is totally impractical. So to reduce, what we should do is we should increase the frequency of the signal to be transmitted. Now let us consider F, the frequency, as 1 megahertz. So now for this, height of the antenna C by 4F would be 3 into 10 to the power of 8 into 4 into 1 into 10 to the power of 6, and this would come down to 75 meters. So with this example we can understand why we need modulation. If you want to send the low frequency signal as it is, then we need an antenna with a size which is impractical, as we can see in this example, whereas if we increase the frequency, then considerably the height of the antenna will come down to a practical size. So this is one advantage or the need why we need the modulation process. Second one is the modulation process avoids mixing of signal. Avoids mixing of signals. Now there will be number of people who will be transmitting the data. For example, if we consider FM stations, we have many FM stations in every region, and everyone will be sending audio signals, and all the audio signal lies in the same frequency band or frequency range. Now each baseband sound signal with the help of modulation will be modulated using a different carrier signal. So different frequency signals will be sending in the same frequency domain. So with the help of this modulation process, we can avoid mixing of signal, without which the audio signals will get mixed up each other. Then the third need is the modulation process allows the multiplexing. So with this, multiplexing is possible. So because this supports multiplexing, multiplexing is all about transferring or handling two or more signals over the same communication channel. So because of this, many signals can be sent together in the same channel. And then the fourth advantage of having modulation is this increases range of communication. This increases range of communication. So because modulation, you know what, like the signals with lower frequencies cannot reach longer distances. So by using modulation, we can use high frequency carrier signals, so we can reach longer distances by increasing the signal power. So these are the advantages of modulation what we have. So this is all about the communication. So we have learnt what is communication, the general block diagram of communication system, and also we have discussed the typical receiver and typical transmitter system, and then we have understood what is modulation and what is the need of modulation. Thank you.